Hello class and hello to all my math friends.
Hello, Mr. Waite.
Hello, Mr. Waite.
Hello, Mr. Waite.
Hello, Mr. Waite.
Today we are going to learn how to factor and solve a quadratic equation using the box method. This also works if you are just factoring the quadratic and not solving an equation. Just skip the part at the end when we solve the equation. This method is best used when the value of a is different than 1 or -1. It works for any factorable quadratic equation, but there may be easier ways to factor if a is 1 or -1.
Mr. Waite, please remind me what you mean by a.
Good question, Zorg. A is the coefficient of the quadratic term in a quadratic equation. Let's look. Here is a quadratic equation in standard form. This is the form we want the equation or expression in whenever we factor or solve using factoring. We have it set equal to 0. So 0 equals ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of the linear term x, and c is the constant term.
So, Mr. Waite, can you give an example with numbers, please?
I know. Let a equal 10, let b equal 11, and let c equal -6. Ha. Factor that, Mr. Waite.
Yeah, Mr. Waite. Let us see you factor that bad boy.
No problem using the box method. First let's put it on the board. There we go.
So it's 0 equals 10x squared plus 11x minus 6, correct?
You could not be more correct, Zorg. To use the box method, the first thing we need to do is draw a box. We will make it a square. Then divide the square into 4 smaller squares by drawing segments so it looks like what you see behind me. In the top left square, put the whole quadratic term 10x squared. In the lower right square, put the constant term, -6. Next we multiply a and c. In this case, since a is 10 and c is -6, the product is -60. Now we look for a factor pair of -60 that also adds to the value of the linear coefficient, b. Since b is 11, the sum of the factor pair needs to be 11. So we need to write the factor pairs of -60. One of the factors must be negative since the product of them is a negative number. I picked the smaller factor to be the negative factor because I am looking for a factor pair that adds to 11. So since the sum of the factors is positive, the smaller number of the sum must be the negative number. Now we pick a pair that adds to +11. -4 plus 15 adds to 11, so we choose that pair. Now we put those two factors in the other two squares, except we include an x with each factor since we are solving for the linear or middle term of the quadratic. It does not matter how you choose to put them. Either way works. Now we find the greatest common factor, the GCF, of the top row. In this case it is 5x. We factor the 5x out of the 10x squared and write the result above the top left square. In this case, when you factor out the 5x, you have 2x left, so we write 2x above the 10x squared term. Remember, factoring out the term just means to divide by the known factor. So you can think of the terms on the outside like the length of the sides of the small squares, and the number on the inside is the area, since 2x times 5x equals 10x squared. See comments at the end of the video if you are worried we used a square and not a rectangle for the model. We are very close to being done factoring now. The next step is to use the terms you now know on the outside and factor them out of the terms on the inside. We factor the 2x out of the -4x and write -2 next to the 4x box on the lower left. We factor out the 5x from the 15x and write the 3 above the 15x. We check to see if the constant terms on the outside multiply to -6. They do. -2 times 3 is -6. The factors of the quadratic are the binomials written on the outside of the square. So in this case, it's 5x minus 2 from the left side and 2x plus 3 from the top.
So if we are just factoring, we are done. Yay.
Not so fast, Zorg. I think we should check our answer, right, Mr. Waite?
Excellent point, Haruka. Always check your work. We foil to check. Firsts, outers, inners, and lasts. Then we add like terms and we see our product matches the original expression.
So if we are just factoring, we are done. Yay.
Yes, Zorg. If we are solving a quadratic set equal to 0, we set each binomial factor equal to 0. Since the zero product property reminds us that any number times 0 equals 0. Now we solve these two linear equations where the binomial factors equal 0. The solutions to the two equations are the solutions to the quadratic equation we started with. I'll substitute the solutions into the original equation to check. You can take a look. I'll leave each solution up for 6 seconds, so pause your video if necessary. If you understand this now, you can stop here. We are done and I will answer questions.
Mr. Waite, the box is not really a square, is it, since the sides are not equal in length?
That's correct, Haruka. But the square works well since we don't know the relative lengths before we start. Remember, it is a geometric model.
Mr. Waite, can I use this box to multiply a pair of binomials?
Yes, Troll, you can use it instead of using the FOIL method. In fact, you can use it for doing the product of larger polynomials. See my video multiplying polynomials using the box method. Bye now.